Hello, and welcome to our lesson on angle theorems. In today's lesson, we will start to understand and work with angle theorems, specifically focusing on the vertically opposite angles theorem. Here's what we'll cover. First, we'll introduce the concept of vertically opposite angles, which are created when two lines intersect. Next, we'll use our knowledge that angles on a straight line add up to 180 degrees to demonstrate why vertically opposite angles are equal. Finally, we'll apply this theorem to a variety of examples to ensure you can recognize these types of angles and use our new theorem effectively in different scenarios. Let's briefly revisit what we have learned in past lessons and understand how our work today will build on this foundation. First, intersecting lines. We've understood how intersecting lines form an angle and explored different kinds of intersections. Second, straight line angles. We've learned that angles on a straight line add to 180 degrees. With this foundation, we're ready to delve into the vertically opposite angles theorem. This theorem plays a crucial role in geometry as it allows us to identify equal angles formed by the intersection of two lines. We'll begin by understanding what happens when two lines intersect. Imagine we have two intersecting lines, AB and CD. They intersect at a point O. This intersection creates four angles. For clarity, we can label these angles as follows, drawing on our previous lesson about how to name angles. In this setup, we can identify pairs of vertically opposite angles. Vertically opposite angles are pairs of non-adjacent angles formed by two intersecting lines. This just means that they are angles which are opposite each other rather than next to each other. In this diagram, angles AOD and BOC are vertically opposite angles, and angles AOC and BOD are vertically opposite angles. So, now you should understand what we mean by vertically opposite angles. Recall the fundamental property we discussed earlier. Angles on a straight line add up to 180 degrees. We can use this fact in the example we have here. At point O, the following relationships hold. First, angle AOD and angle AOC sum to 180 degrees. This is because they form a straight line along CD. Second, angle AOC and angle BOC sum to 180 degrees. Again, this is because they form a straight line along AB. Now let's use these relationships to show that vertically opposite angles are equal. Consider the following angle equations that we have just found. Angle AOD plus angle AOC equals 180 degrees. Angle AOC plus angle BOC equals 180 degrees. Since both these equations equal 180 degrees, we can set the left sides equal to each other. So we can write that angle AOD plus angle AOC equals angle AOC plus angle BOC. Notice that both sides of the equation have angle AOC. By subtracting angle AOC from both sides of the equation, we find that angle AOD equals angle BOC. So this has told us that these vertically opposite angles are equal. The same logic applies to the other pair of vertically opposite angles. So we know that angle AOC equals angle BOD. So overall, the vertically opposite angle theorem tells us angle AOD equals angle BOC, and that angle AOC equals angle BOD. Intuitively, we can also understand this theorem by recognizing that the two intersecting lines create symmetry around the intersection point O. This means that the angles directly opposite each other must be equal because they are reflections of each other across the intersection. So think of the two purple angles as being each other's reflections and therefore equal. And the same for the two blue angles. They are also each other's reflections. So let's turn to our final aim for this lesson. Now that we know our theorem, the next task is to be able to recognize these vertically opposite angles in different cases and apply the theorem. Let's look at an example together. Suppose we have these two intersecting lines. Firstly, let's label the diagram to make it easier to talk about. Now we can identify the vertically opposite angles. Remember, these are the ones which are opposite each other across the intersection, not next to each other. So this green pair of angles are vertically opposite each other and therefore equal. And this red pair of angles is also equal. What if we were told that angle POR equals 127 degrees? What would angle QOS equal? Well, since angle QOS is equal to angle POR, then it must also equal 127 degrees. So this is how we can use the vertically opposite angle theorem in practice. Now for some practice. Pause the video here and find the following missing angles using the vertically opposite angle theorem. The answers are on the next slide, so make sure you've answered all 3 questions before carrying on with the video. Here are the answers. First, angle X equals 110 degrees because it is vertically opposite the other angle labeled 110 degrees. Second, angle Y equals 50 degrees. Well done if you got these correct. If not, review the content of this lesson and keep practicing. In today's lesson, we delved into the concept of vertically opposite angles and then the vertically opposite angle theorem, a fundamental result in geometry. We started by considering what happens when 2 lines intersect, creating 4 angles at the point of intersection. Using the property that angles on a straight line add up to 180 degrees, we demonstrated why these pairs of vertically opposite angles are equal. We proved this by recognizing that the sum of adjacent angles along a straight line equals 180 degrees and forming 2 equalities. Upon combining these equalities, this allowed us to show that the vertically opposite angles are equal. Finally, we highlighted the importance of this theorem in solving various geometric problems. By recognizing and applying the vertically opposite angle theorem, we can simplify the process of finding unknown angles, making this a powerful tool in geometry.